Right, so levels 2 and 3 are all about proofs. We are going to prove that the base angles of isosceles triangles are congruent, which means we cannot use this as a reason within our proof. We are given that triangle ABC is an isosceles triangle, and we're trying to prove that angle A and angle C are congruent to each other. In order to do this proof, we need to draw an auxiliary line in. I'm going to create auxiliary line BD. So it is the perpendicular bisector of segment AC. So that means that it would be perpendicular to segment AC, but it would also cut AC in half. So knowing that we did that, we need to state that in our proof. BD is the perpendicular bisector of AC, and our reasoning is we created that auxiliary line. Now, since we know that BD is the bisector of AC, then that means I know that AD and DC are congruent by the definition of a segment bisector. Another thing that I can see right away with these two triangles is that BD is congruent to itself by the reflexive property. And then there's two ways that you can approach the proof from here. How I approached the proof was I used that ABC is an isosceles triangle. So by the definition of isosceles, that would mean AB and CB are congruent. So if I did that, that's the definition of isosceles. And if I did that, then I can now say that these two triangles are congruent by SSS. And then if these two triangles are congruent by SSS, then by CPCTC, we can say angle A and angle C are congruent. Now, you could have went a different route. You could have used the reflexive property and the definition of segment bisector here. But then you could have also did the definition of perpendicular to say that these angles here are right angles. And then you could have said by the right angle congruence theorem that these were congruent. And then you could have proved the triangles congruent by SAS. You could have also either ignored the reflexive property or the segment bisector and proved that these were right triangles by the definition of perpendicular and by the definition of right triangles, and then prove these triangles congruent by HL. So there's many different ways to go about this proof. The only thing is that you cannot use this as a reason in your proof. Now the next proof, it doesn't give us any guidelines as to what we can or cannot use in our proof. So we can use anything in our proof to prove these two triangles congruent. We are given isosceles triangle ABC, and we're given that BD bisects AC. So there's multiple ways to go about this proof as well. What I did was I used that I know that ABC is isosceles. I said AB and BC were congruent. That's the definition of isosceles. Then I used the definition of segment bisector here to say AD and CD were congruent. And then how I went about it, instead of using the reflexive property, which you can use the reflexive property and then use SSS to prove these triangles congruent, I wanted to show you a little bit of a different way. I said that angle BAD was congruent to angle BCD because base angles of isosceles triangles are congruent. Since we're not trying to prove that base angles of isosceles triangles are congruent, that's why I can use that as a reason in my proof. So now I can say that my triangles are congruent by SAS. But again, you could have also used SSS to show that these two triangles were congruent. It was up to you. Now bear with me for number 29. This is going to be a long one, okay? We are given that triangle, and let me make this very large so it doesn't keep popping down on me. All right, we are given triangle PRM is an isosceles triangle. We are also given that YR is congruent to MD. So knowing that PRM is an isosceles triangle, that would mean that we would know that PM and PR are congruent. That's by the definition of isosceles. I'm also going to mark that I know that YR and MD are congruent because that was given in my given. All right. So from here, we also know with isosceles triangles that base angles of isosceles triangles are congruent. So I can say that PRM is congruent to PMR. Now I'm trying to prove that PYD, this whole triangle, is isosceles. So what that would mean is I need the two little outer triangles to be congruent. So from here, I'm actually going to use the linear pair theorem. These two angles here are a linear pair, and these two angles here are a linear pair. So I'm going to state that. Oh, well, first I'm going to state that the measure of angle PRM is equal to the measure of angle PMR by the definition of congruency. That will come in handy in a little bit. You could also stated this later in your proof. Now I have PRM and PRY as a linear pair. That's these two angles here that I'm circling. And I have PMR and PMD are a linear pair. That's these two angles here that I'm circling. Knowing that those are linear pairs, we know that they're supplementary. So PRM and PRY are supplementary, and PMR and PMD are supplementary. That's by the linear pair theorem. Well, if I know that they're supplementary by the definition of supplementary, I can create these two equations. And what I'm going to do is, using that definition of congruency above, I'm going to take this PRM, I'm going to substitute it in for PMR in this equation here. And I have this. So now using these two equations, both of them are equal to 180. So that means I can set both of these equal to each other. That's substitution, or transitive property of equality. And since both sides of this equation have PRM, I can subtract that from both sides to get this. And since they're equal, by the definition of congruency, I can say that they're congruent. So going back up to my figure, now I just proved that angle PRY was congruent to angle PMD. So now those two yellow triangles are congruent by SAS. If those two yellow triangles are congruent by SAS, using CP/CTC, I can say that these two sides are congruent. And if those two sides are congruent, and this whole triangle is isosceles by the definition of isosceles. Wow, that was our first 14-step proof, and you guys survived. Good job. If you need to pause the video to write anything down, or if you need to rewind the video to see anything that we talked about, please do so. All right, 2 more proofs left in this video. We're going to prove the Triangle Sum Theorem. That means that we cannot use that in our proof. We are just given triangle ABC. Since we're just giving this triangle, it may be worthwhile for us to draw an auxiliary line in. I'm actually going to draw an auxiliary line. I'm going to draw segment or line BD. And I'm making that line so it's parallel to segment AC. So I need to state that in my proof. Segment BD is parallel to segment AC, and that's because I created that auxiliary line. Okay. I'm also going to label some new angles here. I'm going to label this angle 4 and this angle 5 because we're going to be using that. If you notice, angle 4, 2, and 5 create a straight line. So by the definition of a straight line, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. You should then notice that if I look at my two parallel lines cut by this transversal, angle 1 and angle 5 are congruent. Sorry, I apologize. Angle 1 and angle 4 are congruent because those are alternate interior angles. If we look at this transversal and the two parallel lines, angle 3 and angle 5 are congruent because those are also alternate interior angles. So I'm going to state that. Now, since I have something with an equal sign in it and something with a congruent symbol in it, I'm going to change those congruent symbols to equal signs using the definition of congruence. Lastly, since I know the measure of angle 1 equals the measure of angle 4, I'm going to take the measure of angle 1 and put it in for the measure of angle 4. Since I know the measure of angle 3 equals the measure of angle 5, I'm going to take the measure of angle 3 and put it in for the measure of angle 5. That's substitution. And guess what? We just proved what we were trying to prove. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Those are the three angles in your triangle, which proves the triangle sum theorem. All right, one more proof to go. This time, I can use the triangle sum theorem as a reason because I'm not trying to prove it. So I'm given the picture. If in this picture I see a triangle, I'm going to use the triangle sum theorem right off the beginning to state that the measure of angle y plus the measure of angle x plus the measure of angle z should equal 180. Also looking at this figure, you should recognize vertical angles. Angle w and angle y are congruent by the vertical angles theorem. Now in order for me to substitute angle w in for angle y up here, I need to use the definition of congruency to get the measures equal to one another. Then I'm going to finish this proof off by substituting the measure of angle w in for the measure of angle y to get what I was trying to prove, which is the measure of angle w plus the measure of angle x plus the measure of angle y equals 180. All right, we just have a couple of more proofs left, but we're going to do that in the next video.